that they produce this Wednesday, and we're just going to make the math simple here. If we want it Monday at 9 a.m., we're going to say it was produced and come off the line Wednesday at 9 a.m. So the question is, how much, if they want exactly 3.5 curies for this person, and we don't want to produce a bunch of extra of this stuff, how much exactly would they have to produce at Wednesday at 9 o'clock so that by the time it got to the University of Virginia, Monday at 9 o'clock, they would have exactly 3.5 curies. So now we know how long this is going to be decaying. It's going to be decaying all the way from Wednesday through Monday. And T here is going to be, well, let's see. It's Thursday at 9 o'clock, Friday, Saturday, Sunday, Monday. It looks like it's going to have the opportunity to decay for 5 days. So our T here is equal to 5 days. So now we know everything except for what the initial activity is at the time of production at Wednesday at 9 o'clock before we use it on Monday. So we fill in our equation and we solve. One equation, one unknown. So here we go. Our final activity we needed was 3.5 curies of the phosphorus 32. We don't know what the initial activity, that's what we'd like to know. E to the minus 0.485 inverse days. And remember, what do we need to have for our units at the variable exponent? We need everything to cross out. So if we ended up with time in seconds or minutes or something, we'd have to convert it. But the nice thing is, we made this problem pretty easy and said the time is 5 days. So days times inverse days, that's the same as having days over days, and so they cross out. So this inverse days crosses out with days, and all you have to do is multiply the 5 times the negative 0.0485 to find out what's up there on that exponent. That negative means that it is going to be decaying away. Anytime you have a negative up in the exponent means that your base to whatever exponent is going to be getting smaller and smaller over time or over distance or whatever you've got going on. Now, don't forget that minus sign. Tell you a quick little story. It help you remember, but a lot of algebra problems are always messed up because people forget the minus sign. And I had a Chinese instructor whenever I was in university class and said, "Ah, Bruce, the road to hell is paved with the lost of minus signs." And so I'll never forget that. I got to be extremely careful whether you're taking electricity class right now along with your nuclear classes and you're solving in electricity class many times for 2 equations and 2 unknowns. Many times there's a negative value that comes up there, and you do not want to lose that minus sign or you'll be way off. All right, so let's find out what 5 days times 0.0485 inverse days, and remembering the minus sign, we find out that this is going to be e to the negative 0.243. And again, no units left. And then solving, what is e to the negative point, putting in that into our calculator, not forgetting, again, the negative sign. We find out that that's equal to 0.784, which makes sense. What we're saying here is, looking at the equation, whatever our initial activity was, we're multiplying it by some fraction, and we're expecting the left-hand side of the equation to be less. And so it makes sense that e to the minus something comes out to be some number less than 1. If it's a number greater than 1, your left-hand side would be greater than your initial value, and then you'd be saying, hey, we're creating stuff instead of getting rid of stuff with radioactive decay. So when the minus sign is there, you're expecting a fraction that's less than 1. Okay? So finally, we just got to divide each side by the 0.784, so we have 3.5 curies. Divide by the fraction 0.784, and the initial activity turns out to be Drum roll, please. 4.46 curies. So Wednesday at 9 a.m., if the customer's going to call in, the customer's not doing your business. The customer says, I need 3.5 curies of phosphorus 32 shipped here on my doorstep so I can use it at 9 a.m. on Wednesday. And you, the company, have to say, okay, well, if it's 3.5 curies and we're going to run the production line of P32 and get this off the line at 9 o'clock on Wednesday, we got to produce at least 4.48 curies of phosphorus 32 so that in shipment through the planes and everything that's flying out to the University of Virginia, it can be decaying away and there'll still be enough for the experiment when it gets there. So this is the absolute minimum quantity. And this is a big deal in the industry. These people that produce this radioisotope, imagine this. What if it gets on an airplane flight and are airplane flights ever late? Do they ever get delayed? Canceled, whatever. There's a whole job, a whole shipping supervisor job that monitors 24/7 at these radiopharmaceuticals that they're tracking and making sure this radioactive substance gets to the customer on time. And if Northwest Airlines cancels the flight, they're on the phones with the airlines getting it on Delta, United, or wherever else to get it there, because if they don't, then it's going to decay away and the customer's not going to be happy. And these packages, oh, you know, $100,000, $300,000 packages, it's a big deal to the industry. So they actually do this math. They know exactly, they usually make it a little bit more curious so they have a little more time in case something goes wrong, but the customer still wants it there at 9 o'clock in the morning on Wednesday. So just another way that exponential decay and or exponential functions are used in the industry. Pause.